learning in your second year, but from this base you will be able to solve that problems also, because all the basics are the series parallel resistors, the kind of terminal voltage problem, the KVL KCL problem. All these fundamentals will be helpful to you in order to solve the electric circuit network analysis problems. Now, now we will be going through problem number 7, series parallel, series and parallel resistances, you can see. Now given data is resistance R1 equal to 10 ohm, R2 equal to 15 ohm, R3 equal to 25 ohm. They have told us to calculate R equivalent in series combination and R equivalent in parallel combination. Now we will be solving first the R equivalent is series combination. Now in series combination, the series combination will look like this. And 25 ohms respectively. Now in series combination, current will be same, as we have already gone through it. Current will be same through each resistance, only the voltages will be different across each. Here the V1, here the V2, here the V3. Now we have to calculate this R equivalent. Now R equivalent for series combination is nothing but R1 plus R2 plus R3, summation of all resistors connected in series combination. Now we will be getting as 10 plus 15 plus 25. It is nothing but 50 ohm. Now in same way, this is the figure for series combination. Now in parallel, some sort of voltage will be applied to this circuit. Where the voltage is applied. The resistor values are given same for this problem also, 10, 15 and 25. Currents will be variable I1, I2, I3. In parallel combination, as the voltage is same and current will be divided across each and every element. This figure is parallel combination. Now we will calculate R equivalent as 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Here we will be getting it as 1 upon 10 plus 1 upon 15 plus 1 upon 24, 1 upon R equivalent. Now we have to solve this. For this, what we have to do is take LCM of denominator. If you go through the tables of 25, you will get LCM, that we have to make the denominator common. Common denominator. Now, in order to make denominator common, we will be have to multiply this by 1 by 10 into 15 plus 1 by 15 into 10 plus 1 by 25 into 6. Now you will get as 15 plus 10 plus 6 divided by 150. 31 by 150, 1 upon R equivalent. The R equivalent will be nothing but 150 divided by 31. The answer will be 4.83 8387 ohms. Just go through it. Nothing has been done. In order to make the denominator common, we have just multiplied by their respective tables in order to get those things, and then we have just calculated the R equivalent. This is nothing, a simple resistance series and parallel problem. Now, next problem. Next problem actually, the problem number 8. In this, R1 equal to 8 ohm is in parallel with R2, which is given as 12 ohm, and R3 is equal to 5 ohm in series with this combination. With supply voltage as 24 volts respectively. Now what we have to find is find the total resistance. R equivalent of the circuit means R total need to be calculated, and current through this circuit you have to calculate. Now I explained you that while starting any kind of problem, you just have to create a circuit diagram for it. Now you will be creating a circuit diagram for this problem solution. Here, first go through the given data. What is supply voltage? It is about 24 volts. Now what they have said, supply voltage, then the parallel resistance, the parallel resistances will be there, and then here this will be 8, this will be 12, and this will be 5. Now what you have to find is the main current and the R equivalent. First we will calculate the R equivalent. Now when we calculate R equivalent, you just have to open circuit the voltage source. Here your circuit will look like this. Eight, 12 and 5. Here the two resistors will be in parallel. 12 is parallel with 8. 12 into 8 divided by 12 plus 8. Just solve for this. We will get as 96 divided by 20. 24 by 5. We will keep it in fraction because we have to add again. The resistance 24 divided by 5 ohm will be in series with 5 ohm. This will be the R equivalent. You will get as 9.8. First we have to solve this parallel combination, then this series 5 ohm calculation. The R equivalent you will get. Now in order to find the current is nothing but voltage divided by current, voltage divided by resistance in any circuit. Now here it will be 24 volt divided by R equivalent. Already you have found out. 24 divided by 9.8, you will get current as 2.44 amperes. As from the problem statement itself, they have already given that the R1 8 ohm is in parallel with 12 ohm and then it is in series with R3. You can also calculate in same way. The 12 and 8 are in parallel, then in series with 5 you will get the R equivalent and then you will be getting this. Now problem number 9. In problem number 9, they have given as resistors 4 ohm, 6 ohm and R in parallel draw total current of 6 amperes at voltage 12 volts. Find the value of R is equal to. Now first construct the diagram for this. What is given? This will be the voltage 12 volt supply. Here the resistors will be in parallel. These are the resistors in parallel. This is of 4, 6 and R ohms respectively. These all are in ohms. Now what they have told, they have given the current also. Current I is given as 6 amperes. Current is given as 6 amperes. Now what they have told us to calculate the R in ohm. Now if you carefully go through these currents are divided. This is nothing but the I for 4 ohm. This will be for 6. This will be for R. You can see from the diagram. Now what we have to do is one concept which actually we have been learned: the resistance, resistivity, conductance, conductivity. Here we will be using conductance, which is denoted by G is equal to 1 upon R Siemens is its unit. Conductance, it is 1 by R. Now conductance will be I upon V as per Ohm's law. Why I am telling you this because we will be using this conductance in this problem, because you will be getting the answer in very short way when we use conductance. Now first we have to calculate the G total, means total conductance. Total conductance is nothing but I total divided by V, which is already given. The I total is given as 6 amperes. The voltage is given as 12. We will be getting G total as 0.5 S Siemens or S. You can see. Now what we have to do is just calculate the conductance for each and every resistor. You will get as G for 4 ohm means G1, you can say G1 equal to 1 by 4, G2 equal to 1 by 6 and GR equal to 1 by R. Now as these all resistors are connected in parallel, as I just said you, the conductance will nothing but the reciprocal of resistance. That's why the GP will be G1 plus G2 plus GR. In this case you can find GT is already been calculated as 0.5, G1 will be 1 by 4, G2 will be 1 by 6 and GR will be 1 by R. Now you can calculate R from this. You can say 0.5 minus 1 by 4 minus 1 by 6 is equal to 1 by R is nothing but GR. You will be getting answer as 0.01 by R equal to 0.0833. Now in problem they have said us to calculate R. R is nothing but 1 by GR. We will be getting as 1 upon 0.0833 as 12 ohms. This is the answer. This is very helpful for your exam point of view because this is somewhat a unique problem which you will be going through Ohm's law. Also you will be going through the concepts of conductance. 1 by R, its unit Siemens, and with the help of this problem, or in order to solve this problem in a simplest manner, I have been using this. Just to go through it. Already you have gone through the theory. Just try to get this problem.